So the first convergence test we have is called the nth term test. And it says if we take the limit of the general term of the series as k approaches infinity and the limit is not equal to 0, then the series diverges. Because if the terms don't approach 0, then we'll just keep adding more numbers and the sum will just keep getting bigger and bigger. However, if the limit is equal to 0, then the series could either be convergent or divergent. So you can't assume that it's convergent just because the limit equals 0. So you'd have to try another convergence test. So for this series, the limit as n approaches infinity of the general term is just 1 over 5. So this is not equal to 0, so this series diverges. Over here, if we just plug in infinity, we get infinity over infinity, so we have to use the L'Hopital's rule. So differentiating once, we get 2 to the n times ln of 2 for the top, and the derivative of the bottom is 2n. So again, we still get the indeterminate form infinity over infinity, taking this limit. So we have to use the L'Hopital's yet again. So ln of 2 is a constant, and then the derivative of 2 to the n is just 2 to the n times the ln of 2. And the derivative of the bottom is 2. So now we can evaluate the limit. And we can see that it approaches, the limit is equal to infinity. In other words, it doesn't exist, which obviously is not 0. So this series diverges also. Here, again, we have to use the L'Hopital's rule because we get the infinity over infinity. So differentiating the top, we get 1. And on the bottom, we get 10 over n, which is equal to n over 10. So this one does not converge either, since the limit does not exist. It's again infinity. So when dealing with convergent series, there are a couple of properties that you can use to combine or split apart them. So if we have two convergent series, then if we add them together or subtract one from the other, then the new series will still be convergent. Also, if we have a constant multiplied by the general term of a series, we can bring the constant out without affecting whether or not the series diverges or converges. And also, removing some number of terms from the beginning of a series also does not affect convergence or divergence. So basically, if we change the starting index value, then it will still converge or diverge the same as it would before. So here, usually we start the index at 0 or 1, and say this series was convergent. If we change the index to k equals 6, then it will still converge.